Hi Bio1. Today we're going to be talking about the biogeochemical cycles, how your biosphere should work, and we're also going to talk about the hydrologic or water cycle. To start off with today, we're going to talk about biogeochemical cycles. So the first thing we're going to do is break down that word. So we've got biogeochemical. Basically everything that works in our environment and in our ecosystems is basically a cycle that deals with how energy flows. So when we talk about bio, we know that means life. Geo is land. This also includes rock. And chemical is going to be the chemicals that are involved in how all of this stuff flows. So today specifically we're going to talk about the hydrologic cycle, which is basically a fancy way of saying water cycle. When you were a kid and in elementary school, you probably drew a hydrologic or water cycle at some point that looked like this, where you had a body of water down here and you had the sun up here, and the sun caused this water to evaporate. That water would then go up into clouds and it'd come down as rain. Well, that's basically what we're talking about today, but we're going to get into some more scientific understandings of it. So to understand this fully, we need to talk about why water is important. So there's a bunch of properties of water that allow us to live on Earth. If it wasn't for water here, we would have no life here. That's also why it's important when they look at Mars and places like that and they find water, because that also leads us to believe that maybe there's life there. Kind of weird conspiracy theory kind of things go on related to that. So the Earth as a whole, 97.5% of the Earth's water is salt water. Then if we take this little tiny piece of the pie, which would be 2.5% of the water on Earth, see that there's like a little tiny sliver right here? Okay, that's because 99% of this is in the ground as groundwater or is ice as frozen water. So this is fresh water, groundwater or ice. This little tiny portion left here, which would be about 1% of the fresh water on the Earth, is found in lakes and rivers. Alright, the reason that's important is because this is the stuff that we really need, or that we mainly use. So the next thing we're going to talk about is characteristics of water. One of the big characteristics of water is cohesion. If I took a penny and I was going to drop drops of water on that penny, you would really think that I could probably get like 10 or 15 drops, maybe. But you're going to be surprised. So what your assignment is, or your lab assignment for today, tell me how many drops of water you can drop on a penny. The property that allows us to put a lot of drops of water on a penny is called cohesion. And cohesion is where we take two of the same things and get them to stick together. So we're going to sum that up by saying like sticks together. The other thing we're going to talk about here is adhesion, which is where water is going to allow other things to stick together because it is a very good solvent and likes things to stick, or likes to bond with things. The other thing we're going to talk about with this cohesion is this idea of surface tension. And surface tension is what is going to allow little tiny pond skimmers to be living on top of this water. And you have seen water skimmers before, probably. I'll use a pencil to draw them so you can get them a little nicer looking. They're going to be these long, thin insects. With antennas and really long legs. Now, these are able to walk on the surface of the water. The thing that allows that is the surface tension of the water and the cohesion where the water molecules are hooking together. That is Big Boy, our rooster. He wants to be included in our video today. Okay, another property of water is, let's look at a lake, but we're going to look at a lake from a side view. So, if this is the land right here, and this is the lake, let's say it is December 28th. The top of our water here would be covered with ice. Not all of the water has frozen, but a lot of it has is ice. Underneath the ice, we have water, which is liquid. Most things, when they freeze, are going to sink because most frozen things are denser than their liquid version. In our case, the ice is going to come to the top because ice is less dense than water. What this allows us to do is that the temperature is very cold outside. Let's say it's like 15 degrees Fahrenheit. That 15 degrees is going to hit this ice. But as you guys can think about it, if it hits this big layer of ice right here, the water down here is going to be warmer than 15 degrees. Also, there's a specific heat capacity of water that is a lot higher than some other materials. And so, if you go out in the lake, we're going to take the same lake here. No ice this time because we're going to say it's July 4th. And we're going to say it's about 100 degrees outside. This water right here could be at 80 degrees. And that's because of the high specific heat capacity. It's going to hold in heat better. So overnight, this water is going to get a little bit cooler, but not as cool as the temperature around. It's also not going to lose heat as quickly and lose energy as quickly. So it's going to hold on to this temperature and stay a little more steady than, say, any other material would be. So now that we've talked about a few of those things, we're going to talk about the water cycle. And we're going to apply it to this picture here. This picture is of Glacier National Park. I found it in a magazine this morning. So the first thing we have happening here is we have water evaporation. And you can see that these are clouds up here. The water is going to evaporate off of this into the clouds. Now, as the water evaporates into the clouds, it does that because of the sun. So there's not really a sun in this picture, but we're going to pretend like the sun is over here. And that sun is going to heat up the water. It's going to cause it to evaporate. Once it evaporates, it's going to condense in these clouds. So we've got condensation up here. See how those clouds look like they're about to burst? So what's going to happen next is we are going to have evaporation. Now, the other thing that will happen is you can see that there's a slope here. When we get water to evaporate from, or to precipitate, sorry, evaporation is it going up, precipitation is it coming down. So this precipitation is going to come down here. What's going to happen is it can enter into the area around it. It can go down into the dirt. And if it does that, it'll be down in the groundwater. Otherwise, it will start to flow this way as runoff. And then it will enter this body of water. Now, the other thing that happens is some of this that goes into the ground will also go into the roots of these plants. And then that's going to go up into the plant, and eventually the plant is going to give that off when it goes through photosynthesis, and then it's going to enter the air again and go back into the whole cycle. So the next question you might wonder is, how does this work with our biospheres? So I have drawn a picture of my biosphere. My biosphere is in a closed jar. I've got 2 plants and a ladybug. I have the bottom here has some soil and has some rocks underneath to provide good drainage. Now, if I start my biosphere with enough water inside of it, it will slowly start this water cycle itself. So I start with the water down here, goes into the roots, goes up to the leaves of the plants, starts to evaporate. I tried to show this here, which is the condensation on the bottle. It's all going to condense towards the top, and then it's going to start falling down. So this is how I would show water cycle in my biosphere. Make sure that when you draw yours, you do something kind of similar. You can do it on the computer, or you can take a picture of it and send it to me. But somehow this week you should have a picture of your water cycle and how it works inside of your biosphere. This is all that we have for our lesson for the week. Make sure that you're working on your biospheres. If you have any questions, be sure to let me know. And there's our mascot of the day, Big Boy. Big Boy. All right, I hope that you all are staying safe and having a very nice time in your time off. Enjoy making your biospheres and get outside a little bit. Bye.